Hello there, this is Sumo Boy, and I am going to try to give you an overview of this measurement lab. Now, what I'd like to do is to have you open the measurement lab on your Chromebook so you can kind of follow through the procedure as I walk you through it here. Oh, yes, just remember that I am watching. Open the measurement lab on Schoology. I think I already said that. All work is going to go into your Chem notebook. So please arrange that cleanly, neatly for Part A, Part B, Part C. Make sure that your values that you're measuring are all labeled and we know what they are. And get whatever glassware that you need from the cabinet at each lab station. I think it's on the south side. There should be 2 green bins, and each lab group you've got all the glassware that you need for your lab station. Please make sure you don't get that mixed up, that if you take something out of that, make sure you put it back in. Okay? So when you go into the lab, you're going to see that there are different stations set up. So if you are looking at Part A says that you are measuring the dimensions of regular geometric shapes. And in this part of the lab, you're going to be using the ruler, and the ruler should be right there. And I would suggest magnifying glasses. And you need to get a circular object, and you need to get a sheet of paper. And directions tell you you're going to measure the length and width of the piece of paper, and then you're going to calculate the area. And you're going to do the same thing to the circle. You're going to measure the radius or the diameter of the circle and calculate the area of the circle. And I think the last thing that I'm going to ask you to do there is to convert your answer from square centimeters to square millimeters. That's Part A, and that is in the corner of the room. Part B is right next to it. Isn't that handy? And in Part B, you have a beaker of sand, you have scoops, and you have a balance. You are going to need to get a 100 milliliter beaker from your buckets. And with that 100 milliliter beaker, I'm going to ask you to measure the mass of the beaker. You're going to put 2 scoops of sand, and then you're going to put the beaker and the sand on the balance and measure the new mass. And from that, we want to find out how much sand, what the mass of the sand is in the beaker. One thing that I'm going to ask you to do when you pop the cover on this, which means you lift it up, and when you're putting sand in your beaker, please don't do that over the balance. Okay? You're going to spill some sand invariably, and I'd rather not get that on top of the balance. That's just kind of bad chemistry. Okay? Now, Part C is actually set up in one of the near lab stations. So what we've got is a 1,000 milliliter graduate cylinder, a 100 milliliter graduate cylinder, you've got a 10 milliliter graduated cylinder, and you have a 100 milliliter beaker. In each of these, I have some water. And what you're being asked to do is to measure as precisely as you can what the amount of water is in each graduate cylinder. And I would encourage you again, look at the lines that are on each of the graduated cylinder and decide what are they equal to. Okay? There are also, right there's some magnifying glasses. If you want to use a magnifying glass when you're looking at something, you are certainly welcome to do that. The second part of Part C is when you are measuring the volume of a regularly shaped solid. There are cylinders of aluminum in the box, and you can take one of those cylinders out and you can measure the volume of that cylinder using the rulers. Okay, and you might need to look up what the formula is for the volume of the cylinder. But that's part C. Please don't take these away from this table. You can move them, but leave them on the table, and don't put any water in or take any water out, please. Part D, you have 2 bottles of distilled water and 2 bottles of isopropyl alcohol. You are going to need to get the 10 milliliter graduated cylinder that's in your glassware bin. And what I'd like you to do is to put about 4 to 5 milliliters of, well, before you do that, it says you're going to need to measure the mass of the dry cylinder. And then you're going to put some water in there and put it back on the balance and measure the mass again and come up with the mass of water. And then what we're going to ask you to do is to calculate the density, which you know now to be mass over volume. There, I can write. Okay? Once you do that for water, we want you to do the same thing for the isopropyl alcohol. When you're done with the isopropyl alcohol, you can pour that down the sink. Okay? So far, so good? The last step that you need to do, and then we come to part E. And in part E, you have a box containing a bunch of pieces of copper. You can take either 1, 2, or 3 pieces of copper. First thing I would do is to make sure you measure the mass of the copper. You can just lay those right on top of the balance pan. I would do this first before they get wet. Then get a graduate cylinder and you're going to put a set amount of water in it, and you're going to put the copper in, and then you're going to make another reading to use to get the volume of the copper. And once you've got that, again, you're going to calculate, oh, that's interesting, let's try that. You're going to calculate the density of the copper. And what I'd like you to do then at that point is to look up in your Chromebook what the actual density of copper is and calculate your percent error. Now, if you don't know how to calculate percent error, I would go into the ICANN statements, and the one that pertains to percent error, I would open up the link on that and look at what the formula is for percent error. And then finally what we're going to do, and we might end up doing this on, what day would it be? It would be next Tuesday. We're going to put our copper values on the board and we're going to graph them and see what we get for a graph. It'd be a mass volume graph, and it'd be a class data graph. But if we don't have time to do that tomorrow or today, whenever you are watching this, then we'll do it the next class period. Okay? So please be mindful of everybody else in the lab. If there's a bunch of people, you don't have to do this in sequential order. You don't have to go A, B, C, D, E. You can start with E. You can start with any station you want, wherever there's space. And you don't have to work at that station unless you are, you can take the material and you can go back to your table or your lab station to work when it's feasible. Okay? Good luck.